Over the last 11 years, MPSG's on-farm network has hosted more than 100 soybean seeding rate trials. Here's a quick aerial image of one of those trials near harvest. So seeding rate decisions start with deciding what living plant stand are you targeting. We recommend a living plant stand for soybeans between 140 to 160,000 live plants per acre to maximize yield. So that's where we're starting. From there, we're adjusting our seeding rate to account for germination, vigor, and expected seed survival. We seed those seeds, and the actual plant stand that establishes in the field, we can measure that using plant counts. From there, what we're actually achieving in the field, we can circle back and inform our future seeding rate decisions. Investigating seeding rate in our on-farm trials, that's how we're getting statistically significant yield results on this yield outcome bullet at the field scale with our existing equipment. But before getting into the on-farm trials, I wanted to go over the original research that determined that ideal living plant stand in Manitoba to target. So this small plot research study was conducted by Ramona Moore at Ag Canada in Brandon. There were 8 sites across Manitoba, from Melita to Beausejour, Roblin to Arberg, and at research stations in between. So here, yield is calculated across row spacings, sites, and years, and as a percent of the maximum yield that was achieved at each site to give us relative yield. So from where this data is plateauing, that's where we get that recommendation to target the live plant stand of 140 to 160,000 plants per acre, highlighted in purple, to maximize soybean yield in Manitoba. What we can also see from this data, though, is lowering plant stands from 120 to 140,000 plants per acre, highlighted in blue here. That's still within 5% of our recommended range for maximizing soybean yield. So with that brief introduction, I want to talk about some of the on-farm trials investigating seeding rate. There was a desire to test seeding rates on-farm at the field scale with farmers' existing equipment and management strategies to really dial in farm-specific seeding rate decisions. Soybean seed's quite expensive, so there was that desire to know if we could reduce that input cost by lowering seeding rates. Would lowering seeding rates impact yield? And also, were we leaving any yield behind already with our current seeding rates? Would increasing the seeding rate impact yield at all either? So these trials kicked off in 2012, and we've had anywhere from 7 to 15 seeding rate trials each year since. So that's adding up to 107 seeding rate trials over the last 11 years, and they're all shown on this map. We've tested a range of seeding rate combinations, depending on what each farmer is interested in, but the minimum requirement is a difference of at least 30,000 seeds per acre between seeding rate treatments. We're using 30,000 to make sure that the treatments are different enough from one another that there's the potential to see some differences in agronomic performance and maybe yield. Other than that seeding rate, the field and trial area have been managed normally using a farmer's typical management practices. Since the seeding rates are specific to each farm, the distribution of seeding rates we've tested across this network of farmers is pretty widespread. So we're comparing 3 seeding rates at each trial. Most commonly, we've had trials comparing 130 to 160 to 190,000 seeds per acre. The next most common has been farms starting with 180,000 seeds per acre and comparing that 180 to 150 and 210, just to get that range. A little bit of background on these trials so far. Since it's 107 trials, it's not as easy of a data set to summarize briefly as some of our other trial types. But of these trials, 60% have been seeded with an air seeder and 40% have used a planter. In terms of row spacing, half of the trials have been on narrow rows, less than 12 inches, a third on more intermediate row widths of 15 to 20 inches, and 17% of trials on wide rows that are 22 or 30 inches. The average seeding date over the last 11 years in these trials was May 19th, but they're broken down by year on the side in this table. So 2022 was a late spring with an average seeding date in these trials of May 28th, but these trials that also had later seeding dates on average did occur also in May 2014 and 2015. In terms of crop stubble and what soybeans were being seeded into, 34 trials were placed in where the previous crop was wheat. 21 trials, the previous crop was canola. 18 were soybeans on soybeans, and then 10 or less of each were on winter wheat, corn, oats, or another crop. We've tested 57 different soybean varieties so far in these trials as well. So in all of their on-farm trials, we evaluate plant stands by taking plant counts. And this is telling us how many plants are establishing from the seeding rate in the field, and also how many of those plants are surviving to harvest. Are we seeing any plants dying off throughout the season from some competition? In these seeding rate trials, we count a lot of plants. Each treatment strip, we count 10 feet of 2 rows at 2 different spots within that strip. So the first plant count that we take at all those locations is during the early V stages. Once all of those plants have emerged, then we're flagging it and we're revisiting those same spots closer to harvest to take a second plant count and see how things are changing throughout the season. And we can use those plant stands and compare them back to the seeding rate. In these graphs, we have the seeding rate along the bottom and then the actual plant stands that were in the field at both vegetative and reproductive growth stages. These orange lines are the 130, 160, and 190,000 seeds per acre seeding rate comparisons. So for example, on average, this 190,000 seeds per acre seeding rate produced a live plant stand of 150,000 plants per acre during the vegetative stages. At harvest, or closer to harvest, that 190,000 seeds per acre resulted in 140,000 plants per acre on average, roughly. So what I'm wanting to draw your attention to here is that there's actually a lot of spread for what plant stands are being achieved based on our different seeding rates. There's a lot of variability. But on average, during plant establishment early in the season, across seeding rates and trials, 81% of the seed put in the ground survived to produce a living plant. By our stages, closer to harvest, the number of plants that survived to produce yield in the end was reduced to 76%. So there was an average loss of about 5% of plants over the growing season. What that meant was that on average during plant establishment, a seeding rate of about 175,000 seeds per acre was required to achieve that live plant stand recommendation above 140,000 plants per acre before flowering. To get that same plant stand at harvest, now 190,000 seeds per acre was necessary. One question that often does come to mind regarding soybean survivability, how many plants are actually establishing from that seeding rate, is equipment. Is it playing a role? So air seeders are typically expected to be a bit tougher on the seed. And I mentioned earlier that it's been a 60-40 split in these trials of air seeder to planter. On average, what we've seen is for planters, 82% survivability. And also for air seeders, 80% survivability with an air seeder. So the gap between the two hasn't been as great as we previously thought, but there is quite a range within each of these two where we can certainly dial things in and get better establishment and survivability. What we have been doing a bit more recently with these trials is getting a bit more information on seeding equipment to see if we can tease this out a bit more. Disc drill versus hoe drill, those kinds of things. But for now, we're seeing actually really good establishment using both types of equipment on average. But what do those different plant stands mean for yield? This graph is showing yield by early season plant counts for each seeding rate treatment of each trial. So the treatments were seeding rates, but different field and seeding conditions resulted in different living plant stands. While the general trend from this data is that as plant stand increased, yield grew. Ultimately, from the spread of this data, though, environment in different fields and years is playing a bigger role than seeding rate in determining yield. It's a pretty wide spread. This is also showing us, though, that the outcome of seeding rate is very farm and field specific. We're getting different results on different farms and in different fields based on how many plants are actually establishing from that seeding rate. I was also curious to investigate our bigger yields from this data set to see if they had anything in common. So this is that same graph now showing the different years. It's color-coded by year. From this data, there were 36 treatments and 17 trials that resulted in yields above 50 bushels an acre. More than half of those big bushel yields were from 2016 and 2022. Ultimately, we had plenty of moisture there for pod fill. That's where that came in. Otherwise, the majority of these trials were seeded on narrow rows, had seeding rates above 160,000 seeds per acre to achieve these higher yields. That's what those trials had in common. But what yield responses were statistically significant? How frequently did we actually see a change in yield with changing seeding rate? Of 107 trials, there have been 19 where increasing seeding rate improved yield, or 18% of the time is what this little pie of the chart is showing. At soybean prices of $15 per bushel, the yield increases were large enough to pay for that extra cost of seed at 14 of those trials, or 13% of the time. So what we're finding in these trials is that seeding rate is really only resulting in a statistically significant yield response 1/5 of the time. When it is significant, the yield increases do more often pay for the extra seed. But at the end of the day, most of the time, changing soybean seeding rate has not impacted soybean yield in on-farm trials so far. Let's explore the more common three-way seeding rate comparisons in a bit more detail, since we can directly compare these different seeding rates. So on the top, we have 130 versus 160 versus 190,000 seeds per acre. And then the bottom is 150 versus 180 versus 210,000 seeds per acre. We have that also listed in units per acre and the cost of those different seeding rates if we're assuming roughly a $68 per unit price. So each 30,000 seeds per acre change in seeding rate is roughly a difference of $14.50 per acre. So here are the average early season plant stands and percent of seed that survived from the seeding rate. What we're seeing is at higher seeding rates, a greater proportion of seed is not establishing. So that's a difference of 7 to 11% of seed, 7 to 11% of seed between the low and the higher seeding rates. Later in the season towards harvest, here are those plant stands again and their percent survivability. What we're seeing later in the season is that the margin of plants lost from B to R stages is wider at higher plant stands. The more seeds in the ground, the more we've been losing. So this is showing us that there might be more competition happening among soybean plants at these higher seeding rates as well. In terms of yield, however, the general trend was that as seeding rate increased, yield did as well. But we need to use statistics to tell us if those yield results are actually a result of the seeding rate and how often that's occurring. So when we compare the seeding rate, here's 130 versus 190,000 seeds per acre, and this had a significant yield advantage to the higher seeding rate, roughly 1/5 of the time, where 190,000 seeds per acre on average increased yield 1/5 of the time by 2 bushels an acre. Then if we're comparing 160 to 190,000 seeds per acre, on the other hand, that's a less frequent yield response, only 8% of the time, and a smaller yield response on average than comparing 130 to 190. If we compare 150 to 180,000 seeds per acre, again, about 1/5 of the time do we see a response with higher yields at 180,000 seeds per acre, on average improving yield by 1.3 bushels per acre. And then comparing 180 to 210, again, a less frequent and smaller yield response. At $15 per bushel sell price, gaining more than a bushel in return becomes economical. Everything was an economical yield increase, except for the 210,000 seeds per acre. There wasn't that return on investment there. So what was the economical choice when we look at all of the comparisons we've made over the last 11 years, all those different seeding rates? Results so far indicate there's a lot of variability farm to farm and even field to field in the plant stands that result due to those different seeding rates. A seeding rate decision made on your farm should include your own observations. Take those plant counts and compare that back to your seeding rate. But our general economic summary so far is that seeding above 200,000 seeds per acre hasn't provided a consistent return on investment. Seeding at 190,000 has benefits over 130, but not often over 160,000 seeds per acre. So overall, there's been a lower likelihood of yield response there. But the general understanding so far has been that seeding rates of 150 to 180,000 seeds per acre has maintained yield and performed well in these trials. And then dropping below 150,000 seeds per acre, that might not have shown a significant yield penalty, but it's introducing a lot more risk. The rest of our crop management, especially weed control, just needs to be excellent to maximize yield potential once our stands are dropping very low. These lower plant stands are less resilient to different environmental stressors and can't handle as many stresses as an adequate plant stand. So in summary, soybean yield has only responded to seeding rate changes 18% of the time. Most often, we can change our seeding rate without impacting yield. The best way to inform seeding rates on your farm is going to be to take plant counts and critically investigate where you might be able to dial in that seeding rate to maximize the amount of plants that are establishing from the seeds you're putting in the ground. If you are interested in learning more about this or any of the other on-farm trials, results are available in this database by visiting manitobapulse.ca or by following this QR code directly there. If you would like to participate in the trial, please reach out to Ian. His contact information is up here on the screen. With that, thanks for your time today to talk about seeding rates. I've been Laura, MPSG's Western agronomist. Also, feel free to follow us on social media to stay up to date on research results like this and more.